Okay, so here we are, our new online edition of Understanding the Automobile. We're starting into our second block, which will be engine fundamentals. First, we're going to discuss um, the four-stroke cycle. Then we'll get into engine components and finish up with lubrication, oil, engine oil, and see where we go. So, after I get done talking, go ahead and click to the next slide. And if you get to a slide and I don't start talking, just go ahead and look over that slide and click on it. If I do a voiceover, it should start at the beginning of any one slide that I put it on. So here we go. All right, so after our brief explanation of the power plant, the engine operation, we're going to cover essentially two-stroke engine versus four-stroke engine. So hopefully most of you have had to mow the lawn or use a weed eater or something of that nature. But have you ever had to mix oil with gas? That's essentially what we're talking about. So a two-stroke engine is also called a two-cycle. So what essentially this means is the power cycle completes with an up and down movement. So a stroke would be either going up or coming down, and a two-stroke or two-cycle engine completes the entire power cycle within both of those. It does use a fuel oil mixture. This actually adds for it to be more compact and lighter. If you think about it, things like a chainsaw or a weed eater, this allows you to be able to put them in different, upside down positions and all this other stuff. Where if you had an oil reservoir and an oil pump like you would in a regular four-stroke engine, that's not going to work. So basically, a lot of lawnmowers, chainsaws, weed eaters. Go back and look at the Word document that I had in there. It should be on the reading list ahead of this presentation, but check that out because I really think. Okay, so what you see here, this crude illustration, I did not draw it. Um, but it does show our two-stroke engine in motion, and you'll kind of notice because the piston's going up and down just one time. That's up as one stroke, down as another stroke, so that's two strokes. And you'll see here how the intake, which is the blue, and the exhaust, which is the gray up in the top right corner, they kind of overlap a little bit, and you get a bit of the fuel air mixture escaping through the exhaust as it comes back into that combustion chamber. Um, does make for this engine to be compact and usable in a lot of different applications. Not real fuel efficient in other applications. So I hope that gives you a little understanding, and we'll move on and talk about the four-stroke cycle. All right, we made it to the four-stroke cycle. I love it. So essentially, the four-stroke cycle is four piston strokes. You're going to have two up and two down, which is going to complete one cycle or one RPM. Anybody know what an RPM is? Uh, Revolutions per minute. So if you've ever driven or ridden in a vehicle that has a tach in it, and the car's running at 3,500 RPMs. Well, that's 3,500 revolutions per minute. That's how fast the pistons are moving inside that engine. This is important to remember here. The crankshaft must rotate 2 times to complete the 4-stroke cycle. And if somebody were a smart teacher, he'd make that a test question. So the crankshaft rotates 2 times during each revolution of the 4-stroke. And this happens in succession very, very rapidly. So we'll move on to each individual stroke cycle and talk about them now. Okay, so here we are in the 4-stroke cycle. Our first stroke is the intake stroke. Think of it as breathing in. We breathe in air so that we can live. Our engine is going to breathe in an air and fuel mixture. Notice up here at the top that there we go, the intake valve is open, and the exhaust valve, which is one that's closed, is closed. So intake valve's open. As the piston's moving down, the intake valve opens and the air-fuel mixture is drawn into the cylinder. Okay, so let's move on. There we go, compression. All right, compression is what happens right before the magic happens. Notice here, both valves are closed, and what's happening now is the piston's moving upward. That air-fuel mixture is now going to be compressed into a tighter area. What this does is we put that in a smaller area, and it makes for better combustion. All right, so here we are, the magic cycle. This is the power stroke. Hey, anybody think of a Ford model that uses some type of power stroke? I wonder where they got that name from. Anyway, power stroke is when the fuel air mixture is ignited with a spark and it goes boom, and that's going to drive that piston down. Notice here also both valves are closed. All right, this is going to be super important, and I'll touch back on that again in just a second. So that's ignited. Explosion causes the head of the piston. It shoots that down. Forces push down on the piston, rotating the crankshaft. You might think, well, how does this all happen? When I start the car, because it's got to have that explosion. Well, that's where our starter comes in, and also timing. And we'll talk more about timing later. But if you think back to automotive history, that's when they, the Model T, when they had to get out and crank that engine around, what they were doing was they were manually doing what this power cycle does, and getting everything going that way. All right. Now we're on to the fourth and final stroke, the exhaust stroke. This is where we've just had our explosion. We've burnt that fuel air mixture, and now we need the engine to be able to put those particles out. Now you'll notice here the exhaust valve is open, and we'll talk just a little bit more about how many valves open during the cycle. But our exhaust valve opens, and that allows for the burnt gases and whatnot to escape through the exhaust port and into your exhaust system. Okay, so now we're here and we can see the complete 4-stroke cycle. Remember that your crankshaft is going to have 2 revolutions. It's going to turn 2 times to complete one cycle, and we have our intake valve open on the intake stroke, Piston's moving down, drawing in that fuel-air mixture. The compression stroke, the piston's moving back up. Both valves are closed. We have to have a tight sealed combustion chamber, so that both valves have to be closed for that. Then on our power stroke, and by the way, this is an illustration of a diesel engine. So you see the fuel injector in there rather than a spark plug. We have our power stroke, our explosion, driving the piston back down. And then finally, in our exhaust stroke, the exhaust valve is open, and the burnt fuel air mixture is allowed to escape and go out through the exhaust. I do want to point out that, because this will be a test question, you'll notice that in a cycle, the intake valve and the exhaust valve will each only open one time, and they never open at the same time. So, you know, if you have to say, but you know, the answer is right there in the question too, because the intake stroke, what valve do you think would be open? Why, the intake. Same with the exhaust. The exhaust stroke, the exhaust valve is going to be open. So I do want you to remember the names of each stroke. You need to know them in order, and these are what they are: intake, compression, power, and exhaust. So here we have the four-stroke cycle in motion. So this four-cylinder engine, you'll see, hopefully you see it, that each piston is in a different stroke. There's 4 pistons and there's 4 strokes, so each piston is in a different stroke, and that's what generates all of that wonderful power you'll see there. And you tell me, from your left to your right, you got your firing order is 1-3 and 4-2. 1-3, 4-2. So V8 engines are going to be different. V6 engines are going to be different. Also, depending on the timing that any individual system has, the firing order is going to be different as well. Over on the left side there, you've got the harmonic balancer. That's the large pulley with the dot going around. And then you've got your timing belt or chain, depending on which one it is, and that's the long arrow that's moving down. You'll notice here that dot is going to rotate 2 times to every 1 time that the camshaft rotates. So if your crankshaft rotates 2 times, your camshaft is only going to rotate 1 time. So we get to that portion, and we'll talk about that again in a later video, but your camshaft is going to turn at half the speed of your crankshaft. So this would be a part where I'd say, has anybody got any questions? But obviously you can't ask me a question when you're watching a video. So take note, and let's take a test.